Welcome, everyone. Today we are diving into one of the most transformative concepts in modern technology, the consumption-based model in cloud computing. Let's get started. Let's begin with the what. Cloud computing is essentially the delivery of computing services over the internet using a pay-as-you-go pricing model. Within this ecosystem, the consumption-based model means you don't pay for physical infrastructure, the electricity to run it, or the security guards at the data center. Instead, you simply rent compute power and storage from a provider's data center for the exact time you need them, and when you are done, you give them back. It's exactly like your home water or electricity bill. You only pay for what flows through the meter. If you don't use any IT resources this month, you owe nothing. This fundamentally changes how businesses approach technology, removing the barrier to entry. Looking at our diagram, we can visualize this flow. On the left, we have the cloud provider who owns and maintains the massive physical data centers. They deliver these resources over the internet to you, the consumer. Instead of a fixed cost, a metering system tracks exactly how much compute, storage, or network bandwidth you consume. This usage data then flows directly into the billing engine, which generates a cost based strictly on your consumption. It's a simple, elegant loop that shifts the burden of hardware management completely off your shoulders. Now, let's explore the basics of how this alters corporate finance, the shift from CapEx to OpEx. Traditionally, IT required capital expenditure, or CapEx. This meant massive, one-time, upfront investments to build a data center, buy servers, and install cooling systems. You paid for it before writing a single line of code. Cloud computing shifts this to operational expenditure, or OpEx. OpEx means spending money on services over time, just like leasing a vehicle or renting a convention center. By moving to the cloud, your hardware procurement cycle drops from weeks or months down to minutes. You convert what had been a massive capital expense into an agile, manageable operational expense that perfectly matches your actual business activity. This flowchart breaks down the paradigm shift. The top path shows traditional IT leading directly to CapEx, those heavy upfront costs that lock you into fixed, depreciating assets. You are stuck with what you bought. The right path shows the cloud computing route leading to OpEx, where you pay over time. Because your costs are operational and tied to your usage, it directly provides agile and scalable resources. You aren't tied to aging hardware, giving your business incredible agility to pivot when market conditions change. Why is this model so revolutionary? It solves the age-old nightmare of capacity planning. With a traditional data center, you have to guess your future resource needs. If you overestimate, you buy expensive hardware that sits idle, wasting money. If you underestimate, your data center quickly reaches capacity, your applications slow down, and your customers suffer. Fixing an under-provisioned data center takes a long time because you have to order, receive, and install new physical hardware. The consumption-based model eliminates this guesswork entirely. You have absolutely no upfront costs, and you don't need to manage costly infrastructure that might not be used to its fullest potential. You simply pay for more resources when demand spikes and stop paying when they are no longer needed. Our diagram contrasts the two realities of capacity planning. Starting from the top, we branch into traditional versus cloud methods. The traditional path leads to guessing future needs, which introduces massive risks of either over-provisioning and wasting budget, or under-provisioning and degrading performance. The cloud path, however, leads straight to dynamic scaling. Because of the consumption-based model, this dynamic scaling branches into two massive benefits, eliminating all upfront costs and ensuring you only pay for what you actually use. Let's dive into how this actually works under the hood. When you provision a resource in the cloud, like a virtual machine, the cloud provider creates metered instances for that specific resource. These meters track your usage meticulously, often down to the second or the byte, and generate a usage record that calculates your final bill. But it's vital to understand what you are actually being metered on. If your virtual machine is turned on, you are actively billed for compute power. If you stop and deallocate the VM, the compute billing stops immediately because it is no longer deployed on a physical host. However, you are still charged separately for the durable storage disks attached to it, because that data is still taking up physical space in the data center. It is a highly granular, precise system. This flowchart illustrates the metering lifecycle of a virtual machine. When you deploy a virtual machine, the resource meters immediately activate. We track two main paths here, the compute meter and the storage meter. Following the compute path, billing depends entirely on the state. If the machine is running, you're billed. If it is deallocated from the host, compute billing stops instantly. Meanwhile, the lower storage path shows that durable storage is always billed as long as the disk exists, regardless of the VM's operational state. This emphasizes the critical importance of cleaning up unused resources. A core feature of the consumption model is scalability, which dictates when and how you adapt to traffic. Scalability is the ability to adjust resources to precisely meet demand. We achieve this through autoscaling, which automatically adds or removes resources according to your application's real-time load. There are two varieties to know. Vertical scaling is scaling up or down, adding more CPUs or RAM to a single machine, or lowering specs to save money. Horizontal scaling is scaling out or in adding or removing the total number of virtual machines handling the load. Because you only pay for what you use, if demand drops off at night, autoscale automatically removes instances, and you immediately reduce your costs. You never overpay for idle capacity. Look closely at this autoscale decision tree. At the top, application load changes trigger a predefined autoscale rule. If the rule detects high demand, such as spiking CPU usage, it scales out by provisioning more virtual machines, ensuring that your application performance is perfectly maintained. Conversely, when the rule detects low demand, it scales in by removing virtual machines. This directly leads to our ultimate goal: costs are reduced because those specific meters stop running. The system automatically aligns your infrastructure expenses with your actual user demand. Let's take a deep dive into the specific factors that influence your consumption costs. The cloud is not a flat rate. When you provision an Azure resource, the type of resource, its configuration settings, and the Azure region you choose all directly dictate the price. For example, provisioning the exact same virtual machine in different global regions will result in different costs due to local infrastructure and power expenses. Additionally, network traffic plays a massive role in your bill. While inbound data transfers into Azure data centers are generally free, outbound data leaving the data center is metered and billed based on geographical zones. You also must consider the cloud service model. Using Platform as a Service or PaaS might have a different consumption rate than raw infrastructure as a service, but it offloads routine maintenance tasks to the provider, saving you hidden administrative costs. This hierarchy tree breaks down the four primary pillars of cloud costs. At the top, we have our total cloud costs. Branching down, we see resource configurations, where choices like VM size and storage performance tiers drastically alter the per minute price. Next is geography, reminding us that different data center locations have different baseline costs. Then, network traffic, highlighting the crucial distinction that inbound data is free while outbound data is metered and billed. Finally, the service model, whether IaaS or PaaS, impacts both your direct billing and indirect operational costs. To truly understand the power of this model, let's look at a critical real-world use case: bursting to the cloud during a holiday season rush. Imagine you run a large e-commerce company. In November and December, your traffic spikes by 500%. With a traditional on-premises data center, you would be forced to purchase and rack enough expensive hardware to handle that temporary peak, only to watch it sit idle and gather dust for the other 10 months of the year. In a consumption-based cloud model, you leverage the elastic nature of the platform. You use autoscale rules to dynamically add web servers to handle the holiday surge, paying for them only during those busy weeks. When January arrives and traffic normalizes, you scale the infrastructure back down, instantly cutting your expenses. You only paid for the burst capacity you actually needed. This flow illustrates the holiday burst cycle perfectly. We start with standard traffic from January to October, operating with a low daily cost on a standard server pool. Then, the massive holiday surge hits in November. The system automatically triggers a scale-out, adding burst servers to the pool. Crucially, you pay for this burst only while it is active, ensuring the peak traffic is flawlessly handled without crashing. Once the surge ends in January, the system scales back in, seamlessly returning you to your baseline operations and your baseline lower costs. It represents pure financial efficiency. Finally, let's discuss how you maintain control. Because your bill fluctuates with consumption, financial predictability and governance are vital. Microsoft Azure provides tools like the pricing calculator to estimate costs before you even provision a single resource, allowing you to model different architectural scenarios safely. Once your solution is deployed, you use the Microsoft Cost Management tool to track your resource usage in real time. You can view aggregated costs by billing cycle, by region, or by specific resource tags. Furthermore, to prevent bill shock from accidental provisioning, you can establish automated budget alerts. These alerts automatically notify you via email when your spending reaches a specific percentage threshold of your defined budget, ensuring you remain in complete control of your consumption at all times. This wraps up our deep dive into the consumption-based model. Our final diagram outlines the life cycle of cloud cost governance. Before deployment, you begin in the planning phase by generating estimates using the pricing calculator. Once you deploy resources and begin consumption, that data feeds directly into Azure Cost Management. Here, you actively track your spend through two primary features: the cost analysis dashboards for visual breakdowns of your bill and your predefined budget thresholds. If your consumption triggers a threshold, the system immediately sends an automated email alert, ensuring you are never caught off guard by your monthly invoice.